Now here's one. This is especially useful in AeroAstro. In fact, I need to put up my AeroAstro example for this one. What I did, though, was a ballistic trajectory. What you do is you specify you specify how many points, how many grid points you want. So this is a vector from negative 100 to 100 stepping by 5, and it'll create grid points. This mesh grid business just creates grid points every 5 units. Putting in the original x velocity, original y velocity, the velocity in the x direction is just going to be constant. So it's the original x times all ones. Velocity in the y direction, negative 1/2 at squared. It is proportion. So it'll be proportional to. Let's see.
Why is there a point after the negative 9.8 point?
Remember that's the multiplying. I don't think you really need it. I think this routine.
9.8, should it be like a constant?
Yes, it is. It's a scalar. So I don't think this is required, and I don't think it'll hurt. This point right here, don't think it's element by element. You realize. Don't think it'll help. Don't think it'll hurt. X is a vector, so this point, this dot, is necessary. VXO is a scale. Well, again, it doesn't look like it'll help, doesn't look like it'll hurt. All this is doing here is getting time. 9.8 times time. Acceleration times time gives you velocity, plus the original velocity. Then you do the streamlines. This, you give it the positions, you give it the velocities, and you give it the starting streamline, where it's going to start from. So streamline is a plotting function. But basically, you give it a vector field, and it shows you the stream. It shows you where the next step is in the vector field. It's good for plotting fluid flows, because you give it a starting point, and it follows how the fluid would flow. It's real. This is that old ballistic trajectory example you know from mechanics, instead of fluids. But this is very useful for fluids. Okay, let's run this section, and let me pull this out here. It should overwrite the figure, by the way. It'll erase this one and do the new one. Or will it? Or does it give me a second figure? Nope. Let's see. Run this section, and it's lying to me. Why isn't it doing anything? Okay, I'm going to try this, see if it'll do something. I want to run this section, please. Oh, there it goes. So there's your ballistic trajectory. For some reason, now MATLAB will do weird things sometimes, guys, ladies and gentlemen. I was expecting it to erase the old one and write a new one. It didn't do that. I had to physically erase the old one. So watch out for that. You know what? I think I forgot. Anyway, close. We'll close the figure. In fact, I'm going to just run that in its own section. Close it. There. Close the figure. Here's another easy plot, 3D. This one's kind of cool, too. Run. Oops, I didn't want to run the whole thing. Okay. There we go. I just wanted to run this section. Do I have other windows open? No, it's closed. Okay. Run this section. So there. It plots the sine on the x-axis, cosine on the y, and sine of this on the z-axis from, this is the range it goes, and animate tells it to make a dot. So here's the, I can repeat it. There we go. It's repeating. so I can open the plot tools. Let's see. Figure toolbar there. View. There, that's the one I wanted, right there. And get out of it. Let's see, get out of the select. There, get out of the select. I can, there, let's change the size again to a more reasonable size. I can rotate. Now, I had to go to the figure toolbar, which brings this, all this section up. If I get rid of the figure toolbar, it does that. It just gets rid of it. Now it puts all these commands, including the rotation command, so I can change it around. Have you guys ever seen this on an oscilloscope, for example? We control the horizontal, we control the vertical. For the next hour, we have total control of your television set. You outer limits, anyway. So, yeah, they would show this in old sci-fi shows. Well, yeah, anyway, if you look down on it from the z-axis, it's a circle. And of course, anyway, and of course this is looking at it from, and you view it at different angles, it looks like different things. It's a roller coaster, right? It goes around, round, round. And the dot follows the trajectory. So the red dot follows the trajectory. So this is another easy animation type of thing. Okay. Close it. There's some more we can do. Let's do, and it doesn't like this. Anyway, something happened. I don't know what happened, but won't worry about it. There is a nice little built-in function inside of Matlab called peaks. And where's there? Pull up my figure window, and I better close this one down because I don't think it knows what to do with it if I just do this. There we go. So surf, if peaks is just a data set. It tells you X, Y, and Z data, and it plots it. And here you can rotate, and you can see why it's called peaks. It's kind of just a test data to do stuff. I'm just going to type out peaks, and it'll tell me the function, the actual function it uses. Z equals something something X, something something Y. Well, anyway. Here's the entire function that peaks does. It's just basically giving a routine X, Y, and Z data. Okay. Let's see. The C at the end puts a contour underneath. So here we have the 3D mesh, and then underneath we have a contour plot. We can also do contour all by itself. There. That's the contour plot all by itself. And it should look like the contour plot underneath the peaks plot. And of course, we'd have to rotate. Let's see. Oops. Trouble is, you'll notice the peaks covers up the contour plot. I'm going to go back to contour. There we go. Let's see if we can rotate this to look more like peaks. There we go. That's the contour all by itself. You also have mesh. Mesh is a grid. Surface, let's go back to surf. Surface creates a filled-in grid. Mesh creates just a grid. It's kind of like a fish net. So you'll see the difference between surface and net and mesh. And so you have mesh, surface, contour. So you can fill in the points. You can add contour to mesh too. So you can just add C to this to get contours underneath. Okay. So that's a lot about graphics. You guys already know about axis and title. I made you do that last time. There's a lot more plots. In fact, as part of your homework, you'll have to play around with it a bit. In fact, some of the past homework, you had to play around with that.